first I want to do a quick quiz. Who has never heard of a Raspberry Pi? Everyone in the room, awesome. Who has never heard of Redis? Redis is a key value storage database intended for really fast lookups for specific keys. I'm not using it that way. I'm using it as a publish-subscribe queue, so I can publish messages to it and read messages off of a queue. So already we're kind of out in the weeds. Who has never heard of LEDs? Who has never heard of Mario? Mario is a fictional character in video games created by Shigeru Miyamoto and popularized by Nintendo in 1981. Okay, I am James Alexander. You can find all of my slides here at jamesralexander.com. There's just too many James Alexanders in the world for me to get my actual name as a domain name. I work for Leaf Software Solutions as a systems engineer. We do these types of things. Probably for this group, maybe you might have Microsoft CRM need or a Microsoft Dynamics need. So if you have an installation or a maintenance upgrade or any kind of type of maintenance you want to do on that, we have a team that can supply those types of needs for you if you have those. So what's our motivation here? Why are we doing this in the first place, Keanu? No big whoop, it's coffee talk, right? So I kind of have to actually ask you to be with me a little bit on this, because this is definitely an engineering Rube Goldberg machine. Like, it's a really complicated way of solving a simple problem. Like, back here we can see a chalkboard that does the same thing. Literally, there is a whiteboard on our refrigerator that we could just write on to say, we last made the coffee at this time. But I decided that's not good enough. We need to do something better. So first off, the hardware. It's all made possible by the scale you see here on the left. This is a Dymo M10 pound scale. It's intended for postage. So the idea is that you are trying to ship something, you put a package on it, and you get the weight, and you can ship it off. It is USB enabled. So you plug a USB into the back of the scale, you plug in the USB to your Raspberry Pi, it gets powered directly off of the USB, and it can read, the USB device shows up as a human interface device, according to Raspbian on the Raspberry Pi, which is over here. And then this is the LED panel that I'm referring to. This is off of Adafruit. It's a 16 by 32 pixel display, RGB, that I will get to and show quite a bit more in a bit. I found this specific scale from the GitHub library here at the bottom of the scale, where I first found the idea of there are USB compatible devices that I can just plug into Raspberry Pi and get immediate support for it in Linux without any extra, running drivers or any extra work. So I found on here, there's 5-pound scales, there's 35-pound scales that kind of all do the same type of thing. I weighed a full pot of coffee from our coffee machine, and it weighs right about 5 pounds. So I didn't want to go with the 5-pound scale, because it would be constantly maxing out the scale. Someone jams the pot down on the scale, you got to max out your scale and potentially damage it. Same with 35 pounds, it seems like too much. So I kind of went within the middle of the road, the 10-pound scale here. Any of these are probably going to work. This is just like a product ID and a manufacturer ID tuple that are in C code here. But any of these theoretically should work with Python and in your project. So how do I have it wired up? In probably one of the worst ways possible. I've just got 2 little DuPont jumper cables jammed into a wiring harness here that is really flimsy and chintzy, so if you move it or jostle it, or in our case it's on top of our fridge, anytime you open and close the fridge door, it shudders a little bit, and so these wires can come shaking out a little bit. But in general, they stay mostly in place. When they don't, I just consider it a feature, because now the LED panel kind of goes a little nuts. Like, you get artifacts and extra colors all over the place. So a better way, if I were wiring this today, I would buy this little adapter board. It's an extra $15 board that goes on top of a Raspberry Pi 3. And it plugs into all of the 40 pins on the Pi 3. And it gives you a way to just plug in these additional IDC connectors to it. In addition, you can see here that you can easily chain 3 of these displays together and have 3 displays all at once, rather than just the single display that I have wired on my machine. I want to mention the GitHub library here, the repository that makes this all possible. When I found the C library first that had the listing of possible scales that would work, a coworker found this RGB LED matrix library that includes the wiring diagram, included initially just some C code that would drive these LED displays. And so it ends up being just a CLI program where you would say LED matrix and -T, and you would pass it the text that you want to display, and it would scroll, and a scrolling marquee passed on your LED for what you want to display. You could also send in images, and you have some basic shapes and geometry that you could pass on the command line arguments. More recently, in the past 9 months or so, Henry Rosello, the library author, added Python support. So this is C-bound Python that gives you all the same interfaces that you can draw more specific shapes, you can draw text, you can specify each pixel what RGB value you want it to be. So this library is what makes all of the following possible. When I first wired up my display, I got this. This is supposed to be a rotating square. You can see it's not quite there. More to the point, it's supposed to look something like this once the rotating loading icon shows up. So that's your hello world of getting your LED wired up correctly. Our history with Wi-Fi and Raspberry Pis has not been too good. So it's always kind of flaky, it just drops out for no apparent reason. So we set up this script. Actually, more likely we found this script from someone else that had the same problem. What this is going to do is it just pings our router. If we get an error, we just say, all right, take down the interface, and then bring it back up again after 10-second wait. And that's good enough. So far, we've had 0 issues with this particular type of setup. Another thing that this is good for is that every now and then, our system administrator will change our Wi-Fi password to our Wi-Fi network. So what I do is I say SSH in on the morning, change the password to the new password that will be after he changes it. This will fail between the time that I change it and when he changes the password. And then once the password changes, it'll see the new password, come back up, and I have access to it again over the Wi-Fi. So some software design. This is a really rough diagram that I put together, but essentially it's going to look like this. The scale will send data to a script that I've got, coffee_scale, and this script will push messages into Redis, and the push message will include the name of the script that I want to run that will drive the animation on the LED panel. If it's either an animation or it'll be just fixed text to say that, at this time, the coffee was lifted, and this is how much coffee is in the pot at that time. First, we need to read data off of the scale. So this is a binary read. We're reading 16 bytes off of the Python file here. And then we unpack it with struct into a tuple. So regardless if you send a single character or if you send multiple characters, you're always going to get a tuple back when you unpack off of your binary read from struct unpack. You can pack more than just integers here. And here's the table on different types of things you could read off of binary mode from here. Here's the full function that reads off of the human interface device here. In my experience, even unplugging and plugging back in, I always showed it on dev 0, and presumably if you have more, that will show up as dev 1, dev 2, so forth. I've always had a single scale, so I never had any issues with that. Standard, with context here, opening up read binary on the interface device, and it reads like any other file in Python. In a moment here, I'll mention that this particular statement was giving me fits. On the Raspberry Pi 1, I had no issues at all. But when we moved to Raspberry Pi 3, the read statement was hanging. It wouldn't throw an exception, and it wouldn't time out. It would just sit there continually. And I noticed this because I would turn off my supervisor, and I would just run the script manually from a tmux session, exit out, and come back in. Once the display was no longer responding. Like it's supposed to respond every time you lift up or put the Coffeebot on the scale, and it wasn't doing it anymore. When I'd Control-C, I would notice that there was that line that was hanging. And I don't really know why. I presume that the scale was slightly losing power, or it couldn't read 16 bytes of data off of the file, or some kind of voltage drop maybe, but there was some reason that, for whatever reason, the read would never complete. So what I did to compensate for that was I imported this signal library. So this only works on Unix, but since it's only going to be on a Raspberry Pi, I don't care. And I just say, if I haven't heard from you in 5 seconds, throw an exception. Call my handle alarm here, which is raised in an exception, and then it will continue my infinite loop. So it'll try again, after 5 seconds of inactivity. So that's my kind of hack job of seeing if I can get out of this, hanging position of trying to get more data off of the scale. We're doing other interesting things here, like because we've got so much data, a single data point coming off of a single scale, we have to have web scale, right? So we need to write to a DynamoDB instance here. And then, of course, we're writing to our LED Redis instance. Here's the code that actually will send the data to Redis, the string. So if we're sending how much weight is on the coffee pot, we're sending -t, how many mugs, and this is kind of a little hack job. 2 colons indicate a line separator. So I've got just enough space on my 16 by 32 panel for 2 lines of text, and basically 8 characters wide. So my single string divided by 2 colons will tell me that I want 2 lines, and I'm just going to call fixed-text here, and then that'll display 2 lines on the LED panel. Here's some other possible animations. I'll show some of these here in a minute in a video, and you'll notice that I'm not conforming to PEP8 because I've got dashes in all of my script names. I apologize, I'm a horrible person. I'm getting away with it because these are the end scripts that get called. They're not being imported as modules. Because if you try to import these as modules, you would get syntax errors in Python. It would just throw its hands up and not work at all. The first version of this had no display on it at all. So all I had was a pi connected to a scale, and that's it. So when I would pull the pi off of the fridge and get the data off of a CSV file that I was logging to, I would see a graph like this. I was shocked to learn that all of our coffee pot activity happened in the morning. These are all UTC times, and after 4 p.m. noon, nothing happened. So it just sat there in the afternoon. This is the other side after Redis. So this is reading data off of the queue. For brevity here, I'm kind of shortening things up a little bit to get it all on the slide, but this is an environment variable that I'm just replacing with a string here. So you can create a pubsub instance, and I want to subscribe to some channel that I've named on Redis here. Both sides have to be sending to and listening to the same channel in order for you to get messages on whatever channel you're listening for. I noticed when I would just run this script that it would not always respond to a Control-C. And even if it did, it wouldn't necessarily stop the script that I had executed. So if I'm saying it, display fixed text or animate Mario or do one of the other things, that script would not terminate, nor would my listening script terminate. So I added a special message to kill it. So if I send the word kill, it will halt the process that it had executed to start rendering on the LED panel, and it would unsubscribe and gracefully stop listening to Redis after that. Here's the actual script that will start the process. So it's just another Python script. Like I mentioned, there's Python C bindings to start rendering to the LED panel. The LED hardware pulse is an argument that I passed to that Henrozilla library because the Raspberry Pi shares the sound subsystem with the GPIO pins. That library has to have this flag set so that it knows to not render sound. So you set it to 1. -R means I have 16 rows, 16 pixels on my display. And this pulse width modulation nanoseconds value is intended to help me resolve ghosting issues. So when I'm rendering pixels on the panel, I see slight ghosting around whatever pixel I've got rendering. You only really notice this if it's a dark room. So in my office, I can see that there's LEDs that are kind of half on, kind of half off. In the fluorescent bulbs in our office, you can't really notice it, and if you're far enough away, you can't see it, so I've dealt with it. But regardless what I put in for this value, I always saw a little bit of ghosting. So I never quite solved that problem. The library that I keep mentioning made this base class available, so we're going to import 2 classes from his library, matrix and options, and create a base class where all of our resulting scripts are going to derive from. There are a whole lot of options here that get pulled off of argument parser, which Calvin just showed us a little bit more about. And I added, for the sake of my process, this sig term that will gracefully exit the process, because this is essentially going to be an infinite loop. So once you start this is going to just run continually and always keep rendering the pixels and driving the LED panel. On the other side, you can see here now, this is rendering the fixed text. So I'm sending some, creating some random RGB values, and then stripping out the text that I put on Redis. Here's the double colons that I mentioned before. So I'm stripping it into line 1, line 2, and then just drawing both of these at 7 and 14 offset in the matrix, the 2D matrix on the panel. Since the C bindings will continue to push the pixels to the LED panel, all I have to do is keep the script running, and so I just infinite loop sleep 2. These panels are designed to be chained together and put into a giant matrix. So if you see New York Times Square, there's these massive displays of these panels. And so I wanted to see what we could do, and I was just testing how many I could get on a tiny one, like the 16 by 2. So I'm rendering 1, 2, 3, 4 on 2 different lines. These exact same code, all I'm doing is changing the font size. The same library has made, I don't know, a dozen or so different fonts available that are pixel-based fonts. So it'll send out specific pixels for that font. So 9 by 7 is too huge. 6 by 9 is a little better, but it's cutting off both lines a little bit. 5 by 7 is what we ended up using in production because I get the most number of characters that still looks readable. There's a 4 by 6, but we found that a lowercase m and a capital H look very similar in this pixel-based font. And so if I say 4 mugs in the Coffeebot, I don't want to say 4 hugs because now it sounds like your Coffeebot's hugging you. Yeah, for the office, it's not appropriate. The very first version of anything we had displaying data in the break room was this tiny little Spark core. So this is the Spark core here, and we had this tiny little LED panel. This is a micro USB connector for scale. So these things are tiny on the front of our fridge. The cool thing about this particular piece of hardware is that you can flash the hardware or the firmware on this device from a cloud-based interface. So you run a script with whatever new code you want to push to it. This will read it off of your infrastructure or platform as a service, push the new firmware onto this device, and now you can run whatever new code you have on your Spark core. We programmed ours to read from a HIP chat room. So a specific room anyone could type in, and you'd have your text displayed on this tiny little panel here. For the longest time, all our new panel would do was marquee text. You know, it would just scroll text back like this. This is what the C library made available. So you could say -t, send me some text. And in fact, we wrote it such that we would send it an image of text we were rendering, because if we're going to have a marquee, it needs to be in Comic Sans font. This is not Comic Sans, but our first version was all but Comic Sans displaying past. The first script that I ever wrote, I've got a missing slide here, looks like this. Essentially, I'm looping over X and Y, and I set a pixel. I'm just setting it to red here, and anytime you turn on a pixel, you have to turn off the other ones. Or at least that's what I wanted my animation to do. I wanted it to scan each pixel row by row, just because I wanted to see what I could do with it. And then that looks something like this. I don't know if you're on the front row, you can maybe see a little bit of the ghosting that I was referring to, a little bit above and a little bit below the pixel. It's kind of half on, half off. And I never really quite solved that, regardless what I put in for that pulse plus modulation value. I was a Knight Rider fan, so I thought, based on the scanning pixel, I could have it just oscillate back and forth. I've also seen this called Cylon from original Battlestar Galactica. So either way. My wife said, "Can you draw Mario on it?" And I'm like, "I don't know." I Googled 8-bit Mario, and it turns out he's exactly 16 pixels tall. So I was amazed that all I had to do was find this rendering, and then, my first version was just him standing. And so I was like, okay, well, I've got the oscillating pixels, so I had Mario oscillating at first. And then I found one of him jumping, like this guy here, he's jumping. So he would stand, he would jump, stand, jump, do kind of this motion. And then I found all you have to do is 3 different positions, and you can have him run. So now I have a running Mario that will run back and forth across the panel. The first time I tried to do this, I didn't get the midline calculation correct, so he would be kind of Picasso-ish, coming back the other way. So you calculate your midline, and then you just swap your pixels based on the distance from the center of Mario to get him to turn around. Who has never heard of Conway's Game of Life? So this is a cellular automata mathematical game theorized by John Conway in 1971. The idea is that there are a certain set of rules that govern the evolution of cells on an infinite array of 2-dimensional cells. I have 16 by 32 pixels, so it's quite a bit more limited than what John Conway theorized, but once we realized we had a 2-dimensional array of pixels, we said we have to put Game of Life on this thing. One thing I was really surprised by was that if you just send it random RGB values, you end up with something pastel and really kind of pretty. John Conway's original version was just black and white Go pieces on a Go board. And so if you just give it some random RGB, it looks kind of nice. This is one of my favorite initial configurations. With these 7 pixels, it's called Acorn, it will continue evolving for over 5,000 iterations, assuming you had a larger grid. This one, it tops out at just over 700 iterations because my array is what's called toroidal. So if you go off the right side, it loops back and assumes you're on the left side of your array. You have to decide what to do on the edges of a finite grid. So here's what we actually see when we get coffee in the morning. We've got 2 mugs at 10, 11. Since there's no coffee on the scale right now, I display something random. So if there's less than a mug on the scale, or it's been longer than 2 hours that the coffee's been sitting on the scale, I display something random. In this case, it's one of my Game of Life. And then once I put it back on, I see there's 1 mug, and it was 10:30 or whatever it was when I got my coffee. In conclusion, we have some future plans. There's always more to do, since this is kind of a hammer in search of a nail type of project. So these displays can be daisy-chained, like I mentioned before. So we wanted to have more. The biggest issue is power. The power supply we have right now is rated up to 2.5 amps. With all of these LEDs on all white, it will almost max out the power supply that we have connected to it. So if we want to have multiple of these things chained, you're going to have a better solution for power. Also, we need to implement the hypertext coffee pot control protocol. It implements additional verbs that are required for making coffee, and they all need to respond, at least in some fashion, to an HTTP 418 I'm a teapot. Thank you very much. Our coffee pot is actually insulated. So most normal coffee pots have like a glass decanter, and there's a heated bottom. Ours doesn't do that at all. The coffee pot itself is insulated, and there's no external heating mechanism. So it's surprisingly how warm it stays, even after an hour. Yeah, exactly.
That was actually my first question as well. How do you keep this hot?
Right. And that's why I say there's like a 2-hour threshold, because by then the coffee is oxidized, and I think that's just no longer good after 2 hours. Because the ideal case was that I wanted to solve for the problem of you're coming in Monday morning and it's 8 o'clock. Is the coffee fresh, or is it from Friday afternoon when the person last made it? So seeing a random animation will tell you it's old, so you have to make new. Yeah. Say again? No, this was bench time. So I came off of a long-running project, and I had some bench time, so I had to decide what to do with myself. And yeah, HR is pounding down my door, like, "What are you doing?" No, this was admin time. So reading data off the scale was just that binary tuple, and when I was reading it off, and when I was debugging and trying to figure out what the format was, I would just do a flat read and then print to see what the scale was giving me. And I found that, always on the fourth tuple, I'd have an integer that represented the same value in grams that the scale was displaying on its little panel on the front of on the scale. So I knew from that how much weight was going to be on the scale in grams. For our DynamoDB post, it's just a simple JSON message. So we serialize it all to a JSON string, and then there's a service that we have written in serverless that listens for that post and then writes it to Dynamo. So we just have a custom JSON format that we use for that.
Are there plans for other sensors in this infrastructure?
In the environment. We also have a...
is the coffee hot still? Is it gotten acidic?
Right. Those are all great plans. What I wanted to do was to have a camera on the front too, to find out who killed the Joe without making any more. But we got OpenCV and all that library. We had that plan, but we got turned down. We didn't get the funding for that one. No, we also have a soda fridge, a soft drink fridge, where anyone can come in, get a soda, and go out. So we thought, how many times does that soda fridge door open and close throughout the day? So that's another thing that we wanted to say, how often does that come up? Also, our recycled trash can, our admin has a very real need, which we still haven't filled yet, of when is that bag full, so that you can go and replace it with a fresh bag. So I think something very similar could be done for that. Just put a scale at the bottom of it, say, all right, when you've gotten a certain threshold of cans in there, send her an email or send her a text or something.
Oh, it needs to be a page.
On her pager, yeah.
On a pager.
Yeah.
Any other questions for James? Yeah, Clayton.
It does, actually, yeah. It's caused... Whenever you walk in now, though, and you see one mug on the screen, you kind of have a disheartened feel like, oh, do I want coffee and make another one, or do I just let it go? So now you have a decision to make. But it was cool seeing everyone's eyes light up the first time they saw Mario running across the screen.
But then they knew they had to make another pot of coffee.
Exactly, once they saw Mario.
Excellent. Any last questions? All right, awesome. Thanks, James.
Thank you.
Give him a round of applause.